Today we are going to see the problem for a chi square. This is one of the problem for a chi square, where it will come under for independence of attributes, where we are going to use the formula for expected frequency. For first I will write the formula which we are going to use. Expected frequencies, that is EI which is equals to row total into column total divided by grand total, where your chi square formula, that is equals to summation of OI minus EI of whole square divided by EI, where we are going to see for degree of freedom. Degree of freedom in the class I have said as what V is equals to n minus 1, where here we are dealing with a row and column. So, you are going to find your degree of freedom, you are going to calculate number of rows minus 1 into number of columns minus 1. This will give you the degree of freedom. Now, we will come for the problem. What they have given in the problem, they are asking to find whether whether there is any significant linking in the habit of taking soft drinks among the categories of employees. They have given the employees, three type of employees they have given: clerk, teachers and officers, and three types of soft drinks they have given: Pepsi, Thumbs Up and Fanta. This is the chi square problem. Now, first we will write for null hypothesis, and when the alpha is not given, you are going to shift for 5% of level of significance. We will take null hypothesis. H naught. What we will do? We will accept that given data what they have given. We will go with that one. There is a significant liking they have given. Liking in the habit of taking soft drinks, where alternative hypothesis, what you have to do? We have to go against to the given whatever you are taking for the hypothesis. We will go against for that one. If they have accepted here, so alternative hypothesis, what it is going to be do? They will reject. It is going to be reject. So, there is no significant linking. There is no significant linking, linking I am saying, it is a liking. Then next, level of significance, will go for 5%, alpha is equals to 0.05. that is a 5%. Now what we will do? First we will calculate what they have given the data. soft drink, soft drinks. Then next clerk they have given teachers, officers, then total will go. Pepsi, Thumbs Up, and next is Fanta. And here also we will calculate the total, row wise total will calculate, even on the column wise. 10, 25, 65, 15, 30, 65, 50, 60, 30. When we are going to calculate this one, how much it is coming? 10 plus 25 plus 65, which is equals to 100. So, in the same way we are going to calculate this one also. It is going to be 110 and this is equals to 140, and now column wise also we will calculate. 10 plus 15 plus 50, right. How much it is coming? It is equals to 75. In the similar way, this is going to be 115 and this is equals to 160, and this grand total, this will give you the grand total. Grand total, how much it is coming? 100 plus 110 plus 140, which is equals to 350. So, 350, the grand total it is coming. Now, see here, when we have added these values, it is giving 350. When we are going to calculate this also, this is also it is equals to 350, where column wise or row wise, when we have added, our grand total is the same in column wise as well as a row wise, that is a 350. Now, what we are going to do? Now, we will calculate for total of expected frequency, where what is the formula for expected frequency? Where expected frequency, row total into column total divided by grand total. Now, for each and every we have to calculate that expected frequency. Expected frequency, we will make a table for that one. Expected frequencies for each and every we have to calculate. Now, this is, see, this is 75. So, 75 to 100 divided by 350 will denote it is equals to E1 will take, or later we will give the numbers then. It is equals to, how much it will come? It is equals to 21.4. When we are going to calculate, that is 75 into 100 divided by 350, which is equals to 21.4. In similar way, we have to cover it for everything. So, what you are going to get? First 75 you do with next one also, 75 into 110 divided by 350, which is equals to, in the similar way we have to finish off, that is 23.6. Next is 75 into 110 divided by 350, which is equals to, not 140, this is 140. So, that is equals to 30. Next with 115, next one it is 115 into 100 divided by 350, that is equals to 32.9. Next, next is 115 115 into 110 divided by 350, which is equals to 36.1. Next is 115 into 140 divided by 350, which is equals to 46. With 160 also you have to do the same thing. 160 into 100 divided by 350 which is equals to, how much it is going to be? So, what we are going to get? 160 into 100 divided by 350, that is equals to 40.71. Next is 160 into 110 divided by 350, which is equals to 50.3. 160 into the 140 divided by 350, which is equals to 64. We have calculated for all the expected frequency. Now we will go for calculating for our chi-square. What is the tabular column for chi-square? That is equals to observed frequency. Observed, we will go for calculating for chi-square. Observed frequency, that is denoted by OI. Next is expected frequency, that is denoted by EI. Next OI minus EI, then we will go for OI minus EI of whole square divided by EI. Now, whatever the data it is given, we are going to write it into the row wise. So, this will be your first, second, third, then fourth, fifth, sixth, seventh, eighth, ninth, in this way. Then in the here also the same thing. How you are taking these values, the same thing you have to consider. So, this was calculated for the clerks, this was calculated for teachers, and this was calculated, and this data was calculated for officers. Now, the same way you are going to write that data over here. So, your first was given, it is 10, then 25, 65, 15, 30, 65, 50, 60, 30, right. Now, this will be your E1, E2, this is your E3, this is your E4, E5, E6, E7, E8, and this is value for E9. Frame the data, that is equals to 21.4, 32.9, 45.7, next is 23.6, 36.1, 50.3, 30, next is equals to 46 and next is equals to 64. Now subtract it. 10 minus 21, 10 minus 21.4, which is equals to how much it is coming, minus 11.4, minus 11.4. In the same way, if you are going to calculate simultaneously, you do that one also. What you are going to get, minus 11.4 of whole square divided by minus, not minus, it is 21.4, that is equals to how much, 6.072 it is there. I will round up and I will write it is equals to 3. So, this is equals to 6.073. In similar way, finish off this data completely, calculate that one. Right. So, all the calculation is done. Now, we are going to do the summation of this one, how much it is coming. The summation of OI minus EI of whole square divided by EI, which is equals to how much it is going to be, 6.073, then plus 1.896 plus 8.151 plus 3.134 plus 1.031 plus 4.3 plus 13.333 plus 4.261 plus 18.062 is equals to how much it is, 60.241. It is a very high, maybe it is going to be rejected. So, now we have to calculate again the degree of freedom. How we are going to calculate the degree of freedom? How many values it is given, number of rows, how many rows it is given, 1, 2, 3. 3 rows are given and how many columns given, 1, 2, 3, it is a column. So, your degree of freedom that is equals to number of rows minus 1 into number of columns minus 1. So, 3 rows it is given, 3 minus 1 into number of columns, that is 3 minus 1, it is equals to 2 into 2, it is equals to 4. At 4 we have to check what is the value it is given at 5% level of significance. So, if we will see in our data for a chi-square, oh god, right, at chi-square at 4, see this is the 4, degree of freedom we got as in a 4 under 5% level of significance we have to so we have to see that is 0.05, how much it is, 9.488, this is the value, this is your V, that is number of rows minus number of columns, it is equals to 4. At 4 at 5% level of significance you have to check, that is 9.488. So, that is equals to that is at 5% level of significance. At 5%, right, degree of freedom at 5% level of significance, that is equals to is 9.488. Now, this is our tabulated value and this is the calculated value. Calculated value, it is greater than the tabulated value. So, the null hypothesis is going to be reject. Just simply we are going to reject our calculated chi square is greater than tabulated value. Therefore, we reject the null hypothesis. Yes, is this clear for everyone? What you have to do when it is this type of problem, it is going to be appear in the exam. This is the way of calculating. Thank you.